your polynomial project. Hopefully you have it, like you could be looking at it now with me. You should have, and you can correct me if I'm wrong, but you should have, number one, some zeros. And I'm just going to make some up. This will be like a pretend going through it. These are nobody zeros because I'm going to make them nobody zeros. I'm going to make mine 0, 7, and 7. Okay, nobody had those because 7 was bigger than a die. Okay, so I have 3 zeros. I could make it also be a negative. We did that from A and B where we figured out positive and negative. If you're at home watching the video, I posted the list of zeros so you know what they were, so you know what your zeros are if you weren't in class. And then number 2, you were just supposed to take those and write it in factored form. So number 2, the best way to look at number 2, and on your project, it's totally fine if you go number 1 and you write these out, and number 2 and you write it out, because then you know you've done all your steps. I could say, well, this is f of x equals, and I've got a negative, so it goes in the front, x minus 0. Factors are always x minus. I don't need the 0 there, but it makes it really clear. And then x minus 7 times x minus 7. For mine, and some of you did have duplicates, you could have said negative x and then x minus 7 squared. You could write it like that if you wanted, because that's the same thing. So zeros, factored form, and you need to know what factored form means. It means multiply together, right? The reason we need it in factored form is because we're going to, if we had been given them in polynomial form, this tells us our zeros. This would work backwards to the zeros. Is it 3? Do you have yours out? Is 3 when we multiply them together? Okay, so 3 says multiply them together. It's a very straightforward direction, multiply them together. So here it is. Now just do the multiplication. So I'm going to say I have my same function, but I'm going to say negative, and I'm going to leave the x and do the x minus 7 times itself first. So I'm going to do this, and this is my rough draft, so I can write on it and make arrows and squiggle marks or whatever. I'm going to multiply this first. So that would be x squared minus 7x minus another 7x plus 49. So next step for me would be to simplify this in the middle. So I've got x squared minus 14x plus 49. Then I have to multiply it by negative x. So my final polynomial version is negative x cubed. Negative times negative is positive 14x squared. Negative times positive, negative 49x. And I don't have a constant in mine. But that's okay because we all have different stuff. So this is polynomial form. It looks like polynomial. It looks like many terms. Poly means many. So I have 3 terms in mine. You probably have 4 terms in yours. You probably have a constant. Then 4 said check all of those, right? And it was specific. So I'm supposed to take my polynomial and use synthetic substitution. I don't need to try 0 because 0 is 0, 0, 0. But if I was going to do it, I would say negative 1, 14, negative 49. Then what has to be my last one? 0. I need a place for everything, including the constant. So if I was doing 0, it would be kind of a moot point, but here it is. Negative 1 times 0 is 0. 14 times 0 is 0. Negative 49 times 0 is 0. 0 plus 0 is 0. Yay! Okay, so 0 works. Then I would try the other one. So I would try 7. And mine are the same. So bonus, I only have to do one of them. I would do, here's my polynomial. Negative 1. 14. Negative 49, and 0. I needed that 0. I need all the places. So these are placeholders if you need it, because you need to start with the highest exponent, 3, and go 2, 1, 0 exponents. So we said start with negative 1, multiply, add, multiply, add, multiply, add. So it worked 0 in the remainder. So I did number 4. I checked to make sure I got 0 at the end. If you don't get 0, you probably messed up step 3. Okay? Because we started with these have to be the zeros. They have to work. Then what? 4 says what? 5 says what? Find the y-intercept. So if I plug in 0 everywhere, a y-intercept looks like 0 for x and a blank. If I plug in 0 into mine, I just get 0. So mine's not that exciting. And then 6 says what?
Write down the degree of leading coefficient for your x.
Okay, what is mine? What's my degree? 3. And what's my leading coefficient? -1. We need that because that tells me what my graph's going to look like. From here, I'm going to sketch it. This is number 7, I think. This is what you need to go through. I have zeros at 1, 2, 3, 4, 5, 6, 7, and 0. And I have end behavior that's negative because it was -1 right here. So mine, instead of going like this, is going to go opposite because of the -1. So it's going to go up here and then down, and then it's going to bounce because this has a multiplicity of 2. You don't know how that works. We will get there, okay? Because I only have 2 zeros, and I needed the end behavior that goes up on the left and down on the right. So this is number 7, and that's what I need you to be able to do with your points for tomorrow. Turn it into me on Google Classroom and bring to class because we're going to check each other's work. And then we're going to talk about, I need for my graph to be very, this is a sketch, but I don't have any idea how low it goes. Mine is kind of a cheater because I know exactly what this point is, but I don't know this value. So we're going to figure out how to find the mins and maxes tomorrow. Not the actual value, because I don't want to use a calculator. I want to just see how far I can get on my own, what I know on my own. Casey, is that your phone? Yeah, put it up. Should be in class. So we're going to figure out this part, number 8, tomorrow. Okay? So 1 through 7. That was a quick summary. It's on a video if you need to go back and look at it as you start to work your numbers and you get stuck. Or you can text the people who were here yesterday. They probably have a pretty good feel for it. That was a summary. Does that feel like what we did yesterday? Okay. Looking at 5.6 on the first day, the first group of problems, all you were supposed to do is make a list of the rational zeros. So if you looked in the back of the book and checked yours, for the first one, you've been like, okay, I just really want to make this list. And then for things like number 7 or 5, you ended up with some fractions. So how about any of those, 3, 5, 7, or 9, when you had to make a list that you would like to see them happen? And the list comes from factors of the constant. They're on top, and then factors, and I'm just going to write LC for leading coefficient on the bottom. So those were good. You can make that list, and you got all the fractions. You checked them. Okay. And then the plus or minus is a pain to write over and over again. But if you just write it in the front and then forget the back, then you may not do all the correct synthetic division. Number 11, 1 worked. And so you could get the other ones by factoring. Number 12, you had to try several things in order to get 12 to work. 13, -1 worked, and that would have simplified your work. 14, I would have factored by grouping first. So 11 through 14, is that all you had to do in that? Yeah, 11 through 14. Any of those you want to see work from beginning to end. So for these, I don't want you to go to the back of the book. I want you to actually try your list of zeros. I want to see this list first, and then you try a couple things. And if they don't work, then you just cross it out and you try another one. Yes, Rachel?
For 14, is it supposed to be 2 -3s or +3?
Oh, it's +3. Sorry. Okay, 14's been fixed. Thank you, Rachel. So this one was harder, but I would have factored it by grouping. No questions at all? Like you get it?
Do 11.
11. 11 says 11. F of x. So this is polynomial form. I need you to know the difference between polynomial form and factored form. So I'm going to keep using those words. Don't just ignore me. Like, make sure you know what it is I'm talking about. This is the multiplied out version. It doesn't have a bunch of parentheses. So this is polynomial form, and we're trying to change it into factored form first and then find the zeros. So first we have to start with a list. So what's my list? 1, then what? Factors of 24. Give me some more factors. 2.
3.
Yep.
4. 6.
Yep.
8. 12. 24.
This I need to see first. It's part of the problem. I need to see it. Then after that, you just start plugging in numbers and seeing if they work. The way we do that is with synthetic division to find out pretty quick, because the math works pretty quick. And if you start with positive 1, you're going to get 1 right away. These are my go-tos. I start here and then I start working up.
Okay.
So if we start with 1, let's start with negative 1 because I know it doesn't work, just because I want you to see that it's okay for it not to work. So if I start with negative 1, then I'm going to write the polynomial down without the exponents, without the variable. And I go 3, 2, 1, 0. So I have everything. I don't need any placeholders. And when I do synthetic division and start with 1, negative 1, negative 13, positive 13, 8, 48. I'm way off, okay? This is not it. So that didn't work. So then I try 1, because usually 1 or negative 1 is going to work. And on a test, for time's sake, it's either going to be 1 or negative 1 to get you started, or there might be a graph to help you pick stuff out. And we're going to look at some graphs in tonight's homework, okay? So that would be like, I don't know where to start. Oh, wait, this is what the function looks like. I should probably start with the one that crosses a number. So I'm going to try 1 now. I've got 1, negative 12, 35, negative 24. So first number, 1. 1, negative 11, negative 11. 24. 24. 0. So that worked. So now this is a factor. When I write it in factored form, I use opposite math. This is a factor, and it was a third degree. So when I divide and get something smaller, this will be squared, this will be x, and this will be just the constant. So constant x, x squared. If you had more numbers, it would go x cubed, like it would go up. And now this is something that I should be able to factor. And I think about factors of 24 again. You could do synthetic division here, but it's a regular trinomial. So we've made charts about how to do trinomials. I'm going to think of factors of 24 that add up to be 11. What are they? 8 and 3. 8 and 3. They're both the same. They're both negative. And that's how I think through that. I've got a bunch of rules in my head. I go looking for factors. I go looking for the signs. Now it's factored. We can set it equal to 0 and find the zeros. That's what it means to find the zeros. We're looking for y to be equal to 0. So instead of f of x, we write 0, and then we solve each one. X equals 1, x equals 8, and x equals 3. Or you could just write a list, 1, 8, and 3. So I want you to make a list. These are the possibilities, but we don't have a way to just write parentheses when it's x cubed, when it's this big. We can't just, like this one I did because it was a squared, and I could just think about it. And Rachel said 8 and 3, like it came to her. But for something this long, it doesn't work like that. There's too many possibilities. So we narrowed down the possibilities with synthetic division. Sometimes we'll try numbers that don't work. In the last set of homework, they told you one that would work. So they might have given you this problem in the last section of homework and said, hey, x equals 8 is a 0. And so you would have started with 8 in synthetic division. Okay? All right. So then tonight, what we're doing for homework is the same kind of thing, except now that you've tried some and you know whether you're good at it or not and how many questions you had for me today, you can run with it. So it's the same exact type of thing, but now we just have to maybe do more synthetic divisions, and some of them may work and some of them don't. But you don't notice how I didn't do synthetic division after this. I went and factored it. So I used the results to factor it further. So I'm not trying to find all of the zeros from the polynomial. I'm trying to whittle it down. Just like if I just took 24 and factored it, I'd say 2 times 12 or whatever, 2 times 6. I don't factor 12 from 24 every time. I don't go, it's 2 times 12 and it's 4 times 6 and it's 8 times 3. Instead, you make it a smaller number that you can then factor, and then you can take that number and factor it again. That's what we're doing here. We're factoring smaller and smaller units. Okay, I gave you one example of using a graph, but let me give you another to start off. So unless there's more questions from last night's homework, more questions? Okay, then what we're doing is finishing this section with 5.6b. And we're saying, all right, so what about if we made a list and then we also had a graph? So let me see, what? (16 through 26 even). Okay, so let's look at this. Example 1 for today is, let's make a list, but let's also use a graph to help us figure stuff out. So here's my function, 6x cubed plus 25x squared plus 16x minus 15. First, I want you to make a list of all the possibilities for zeros. So take a second, make a list. It's going to have some fractions in it because I have a leading coefficient that's different than 1. So make your list. It should say plus or minus a whole bunch of times. And then we're actually going to find the zeros. So my equation, what I use to figure out the list of possibilities, is I'm going through all the factors of 15. So here they are, 1, 3, 5, and 15. I put all of those factors over 1 because that's one of the factors of the leading coefficient. Then I put these same factors over 2. So I've got 1 half, 3 halves, 5 halves, and 15 halves. Then I put all of these numbers over 3. So I've got 1/3, 3/3, 5/3, 15/3. And we talked about this the other day where you could just make the entire list, and if you have a duplicate, like 3 over 3 is the same as 1. So I don't really need that in my list, but I can list it to make sure that I don't miss anything. 15 over 3 is 5, so I don't need that one either. But then I've got all of those same 4 values over 6. So 1/6, 3/6, 5/6, and 15/6. So I already have a half, and this one would be 3 goes 5 halves, which I already have that one too. So even if they're in the list twice, you have them as a possibility, and that's fine. Nobody wants to do synthetic division 8, 16, 17, 18, 19, 20, 21, 22, 23, 24 times, because that'd be awful. So instead, we're like, oh, look, there's a graph. What do I think one of the zeros is going to be? Okay, so these are the This is 1 and 2. Does it go through 1? Yeah.
No.
Okay, does it go through, so this one doesn't go through a point either. This one does. Okay, so in looking at the graph, this is in between 2 points, so it's some fraction. And there's a lot of possibilities for fractions. So maybe I go look over here. This one's probably some fraction, 1 point something. And then this one is -3. So that's the one I want to choose. I want to say -3 is supposed to work. That will take it from 24 possibilities into, let's see if this one works. So try -3 and see if you get 0 at the end. If it is a factor, it will go in evenly. And then see if you can factor all the way to the end after that. Okay, so -3 worked. I got 0. I take this and make it into a polynomial, so 6x² plus 7x minus 5. Does that feel comfortable now? Not so weird? We strip away the x squareds and then we put them back. All right, so now I have to factor this. I only have one choice for 5. I do know that they're different signs because of this negative. And I've already made a list of factors of 6 times 5, which is 30. And I'm going to circle 3 and 10. That's my goal. Because 10 minus 3 would be 7. So 10 and minus 3 would be 7. So in order to get 10, it has to be 5 times 2x. That's going to be 10 and positive 10. And then in order to get 6, this has to be 3x. So let's see, 10x minus 3x equals 7x. So I factored it. How about that? So that's a harder factor, okay, because it has 6 in the front, and those are always more difficult. But if you narrow it down with that list, if you multiply, it's the same concept of where these numbers come from. It's multiplying the 5 times the 6 and thinking of those as the factor. 7 is a result, but not a factor. And then I set each of these equal to 0. So x plus 3 equals 0, 2x minus, minus 1 equals 0, 3x plus 5 equals 0, and solve them. This one's easy, -3, and I was given it from my picture. These fractions, though, you might want to write down so that you can do the math there. So add 1 to both sides. 2x equals 1, divide by 2, x equals 1/2. And then here, subtract the 5, 3x equals -5, x equals -5 thirds. So we were able to take a very complicated cubic function. Remember that if it says 3 here, it's a cubic. We actually named those one day. We said cubic, quartic. We already knew quadratic. And then use what we knew about the possibilities. That's the same thing as a times c. We used the graph, and we found zeros, which is really good stuff. So how about that? Is it making sense? So you got about 15 minutes. You can go ahead and work on the problems that go with this. I'll put them up here so you can look. It's like last night's homework, but it's just a matter of I want to make sure you were following before I gave you some harder problems or added to it. And also we've got the polynomial project happening at the same time. So if you weren't here yesterday and you want to think about working on that in case you have any questions, the rough draft for tomorrow doesn't have to be a project. It just has to be a rough draft of your stuff so that we actually have stuff to work with tomorrow and check your math. Does everybody understand what I'm needing there? Okay.